Everybody say hi, Michelle and TJ.
Hi, Michelle and TJ.
Okay, we are in section 4.5, which is simulations. And I gave you guys this notes yesterday, but we didn't work on them, so we're starting them today. So you should have them. The homework assignment is not online. You guys have a paper that is your homework assignment, and I'm going to have you guys work together in like pairs or groups or whatever, so that you guys can use kind of the same numbers. You can generate the same numbers, whatever, okay? So 4.5 is all simulations, okay? There comes a time where probabilities are very tricky to interpret or very tricky to replicate or come up with a probability. So what we do instead is we run something called a simulation, and that helps us identify how often things occur or how rare things are going to take place, etc., right? So we run a simulation to figure out the probability, okay? So to find probability when tricky to actually calculate probability. Okay, we run simulations when probabilities are too tricky to calculate. Okay, and that's all we have to go off of. We just run simulations and we try to figure out what are the chances that something is going to happen. Okay, so a simulation is a procedure. A procedure is a process that behaves the same way as the procedure. Similar results are produced. There you go. So we're trying to run a simulation. Okay, so here's how this works. Okay, gender selection we have going on here, and we're talking about 152 babies being born. Now we do not have access, nor do we want to poll 152 mothers and have them go through the 9-month process and have them have babies. Like, I don't want to have to track that, so I'm just wanting an instantaneous method of 152 babies. I'm going to pull 152 numbers and see how many of them are boys and how many of them are girls, right? Because otherwise I'd have to gain access to that many mothers, figure out what the gender of their babies were, etc., right? Okay, so in a test of the microsort method of gender selection, development by the Genetics and IVF Institute, 127 boys were born out of 152. I'm going to write some numbers down here. So 152 is the total number of babies, and we got out of that 127 of them were boys. Does that seem like an awfully lot? Yeah, I'm guessing something is happening there, right? Something is occurring that's making me think that, that's not just a random thing, right? That's a pretty big split. If 127 are boys, let's see how many are girls. What would the girl number be? Well, yeah, what is that number? 25. Check me. Ha! That's a big split. 127 versus 25, that's a huge split. Huge split. Okay, so in order to properly evaluate these results, we need to know the probability of getting 127 boys among 152 births, right? Assuming that boys and girls are equally likely to happen, so the probability of boy is 50% or 0.5, and the probability of girl is also 50%. So we're saying they occur with equal likelihood. We want to know, or we want to describe a simulation that results in the genders of 152 newborn babies. So how could we do this to see what our results would be with a 50-50? Right? How could we do this? Like, what could we do to figure out if we do 152 babies or look at the genders, how many would be boys, how many would be girls? How can we use a random number generator to do that? Any thoughts? 152 babies. We want to look at whether they're boys or whether they're girls. That's it.
0 and a 1.
0 and a 1. Okay. So pick 152 numbers assigned 0 for what? Boys? Because boys are zeros. Ha! 0 for a boy and 1 for girl, right? And then we figure out how many of each we got, right? How many boys, how many girls we got, okay? They don't actually want us to run this simulation. Would this take a long time to run this simulation?
Well,
We're just pulling 152 numbers, right? Do you want to try it? Do you want to do
I
it?
already have it.
You already have it? You're like, no, we don't want to count? No? Want to do it? Okay, let's do it. Let's do it. Okay, so let's pick 152 numbers, and let's do that. So zeros are boys and ones are girls. So we're going to see how many zeros we get, how many ones we get out of 152 numbers. I'm going to go to my number generator. Scroll up. Yeah, sure. A little more. There you go. That's at the top. There you go. Random number generator. 152. We want how many zeros and how many ones? Okay. Let me see. When it's tricky to actually calculate the probability. Go back. There? Okay. All right, ready? Okay. Let's run this thing. Here's my number generator, and I already kind of ran one for you. So we want the numbers 0 and 1, because the numbers 0 and 1 are really easy to distinguish between them, right? Like the number 2 and the number 3, if you look at numbers 2 and 3 or whatever, like they both have kind of the same curvature, right? Like 2 and 3 both are curvy numbers, right? So I wouldn't want to pick 2 and 3 because it's not easy to distinguish between the two. But 0 and 1 is a line, 1 is a circle, right? So it's easy for me to count, and it's not tricky for my eyes, right? So that's why we pick 0 and 1. Okay, and I want to run it 152 times. Okay. All right, and I'm going to select the duplicates. You guys have access to this on your Google Classroom. Okay, we're going to run it, and we're going to see how many we have of each. Okay, so here's what I want you to do. Somebody, would you please, write down these running total numbers. Or a couple people. I'm just going to count how many in each row.
Why you count all the zeros?
I'm going to count how many is in each row. Can I do that? Okay. So a couple people, grab a calculator and write these numbers down. Okay. I'm going to count how many zeros. I'm going to count how many zeros are in each row. Ready? Couple people.
Okay.
Couple people do it. Okay. Either write it down or put these in a calculator. Okay. So in the first row, there's 1, 2, 3, 4, 5 zeros. So add 5 plus 1, 2, 3, 4, 5, 6.
Okay.
Okay. 1, 2, 3, 4, 5, 6, 7.
Okay.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5 again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 again. 1, 2, 3 was in that one. Okay, we got a running total.
Yeah.
All right, that was in row 7. Okay, now we're in row 8. Do you see row 8? I'm going all the way to the top. There we go. Perfect. That was not hard to do. 78 zeros. So we're going to put that. That means that out of this simulation, we got 78 zeros, which means 78 boys. And how many girls then? Okay, we could go back through and count the ones, but that would be kind of silly, right? Right? We would have how many girls? How many girls did you say? What? 74. That's a pretty even split. 78, 74, that's not too bad of a split. Okay? So if that was our results for the simulation, I'm guessing that having this as a split is pretty crazy, right? We had a 78-74 split. A 127-25 split is going to be really crazy in comparison to that. What? This is what we got. Okay, so that's a good question. This is what we got by random, right? This is randomly assigning numbers. That's what we got by random. So we're looking at this split, and we're saying, could we have gotten those numbers by just random? Question mark. Or is something actually happening to make me get boys more often than girls? I am guessing something is happening. Something's probably going on. Something is making more boys. Like, that's the most I can abbreviate. Something is making more boys. So the mom is taking something, or something is working. Whatever supplement that they're giving these moms, is making them produce boys more often than girls. Because randomly, I don't think we're ever going to get a 127-25 split, right? It's going to be more even than that. Make sense? Okay, let's go down to the next one. Same birthdays. A classical birthday problem involves finding the probability that in a randomly selected group of 25 people, at least 2 of them share the same birthday. Okay, so let's talk about how many people are we surveying? 25 at a time, right? So I put 25 people in a group, and I want to know the chances of them having the same birthday, month and day, not year, but month and day exactly. Do we have anybody in here that was born in the same month and day? We don't have any twins. Anybody same month and day in here? I don't think so. I don't think so. So we're trying to see that if I group 25 people, what? Who? Very, very nice. So if she was in a room with you, you would qualify, okay? So describe a simulation that we could use in order to find the chances of getting 2 people that have the same birthday. So what could we do? Right, I'm going to pick 25 numbers assigned 1 through 365, okay, and see if we get 2 matches, right? Okay, so we're going to do this one real quick because this I think this fails all the time. Let's do it like a couple times. So trial number 1, trial number 2, 3, 4, 5. We're going to do this 5 times and we're going to see if it's a yes or a no, okay? So we're going to run the numbers 1 through 365 and go 25 times and see if we get any doubles. What? IAL. I spelled trail for some reason. Trail. TRIAL. Thank you. 1, 2, 3, 4, 5. 5 trials. Okay? And we're going to see if it's a yes or a no. What?
I did it and I didn't.
No. You're probably not going to. What are the chances of having 2 people that are the same number?
Slim
Slim to
to none.
none, right? We're going to see if we get any. Okay, so running. We're going to do our min number as 1. Our max number, 365, and we're going to pull 25 numbers. And we want to select duplicates. If you don't select duplicates, you're never going to get the same number again, right? Right? Okay, so that's just defeating the purpose. So run. Out of those 25 numbers, do we get any 2 numbers that are the same? No, we did not.
You
Oh
did.
my
I
god,
did it. I
and
did it
268.
I did it twice and didn't get it.
I can't believe it, dude. How about 36?
That like never happens.
And 36. There's 3.
There's 3 of them. There's 36, 67. I don't know what we did. I don't know. There's 2 68s. What in the heck? So trial 1 was a yes. We got more than 2 people, and that's like wow. That's like never gonna happen again. Holy cow. Yes. That was a yes. Okay, let's rerun it again. Now do we have 2 people that are the same?
293.
293 shows up twice? Are you kidding me?
No way, Cometcher. This is
Why
fake.
do I feel like it's why me?
I literally have done this like 50 times in a row trying to get the same number. And it does not work. And we just got 2 of them that were the same. What? Okay, here's the 3rd one. Do we have any matching numbers there? Any matching numbers there? For some reason, Caleb is like really good at finding the ones because he can find them way faster than I can. I don't know. You don't see any? No matching? So number 3 was a no. We didn't have any birthdays the same. No. Let's do number 4. Here's number 4. Any matching ones? Any matching ones? Nope. Number 4 was a no. Number 5. Here's the last one. Any matching ones?
Yes.
What? 122?
86 and 86.
And 122. What? So 5 was a yes. How did this happen? This is weird. I don't know. We're just lucky. I'm going to go buy a lottery ticket when I leave here. Okay? So this is how this works. In trial 1, trial 2, trial 3, trial 4, trial 5. In trial 1, when I grouped 25 people, we did get 2 matching birthdays. We actually got 3 people that were matching. So like 6 people matching, right? When we grouped 25 more people in trial 2, we did get matching birthdays. Nobody matched in trial 3, trial 4. They did match in trial 5. This is like really rare. I am really surprised that we got some matching ones, folks. I don't know how this happened. But anyway, so that's kind of like the chances of getting matching birthdays. It's not uncommon, right? But I would say it's probably more rare than the results that we got, right? I wouldn't expect it to happen that often, that you randomly have 2 people that have the same birthday, right? Okay? All right, let's go on to the next one. I really like this example. This is interesting. It's a lot of stuff to read, okay? But I'm gonna get down to like I'm gonna skip over some stuff, okay? One of the author's favorite class activities is to give this assignment. Are you ready for this? All students take out a coin and flip it. Students getting heads go home and actually flip a coin 200 times, and students getting tails make up their results. So we have two things happening, okay? Some students are going home and they actually flip. They actually flip the coin 200 times, okay? And over here on the right side, we're going to have the other half of the class that are going to make up numbers. Okay, make up 200 flips. So if I make up 200 flip numbers, I'm going to say heads, heads, tails, heads, tails, blah, 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 and I'm going to go on, right? I'm just going to make those numbers up. Versus these people over here actually have to flip the coin 200 times. And they come back with their result of 200, and the teacher has to guess which category they were in. And he can successfully guess just about everybody. Do you want to know how?
No.
When you're making up 200 flips, when you're like, I don't care.
Let me
I
guess
don't
the
care.
one. Heads, tails, heads, tails.
No, when you're making up 200 flips, you usually will never put 6 in a row of the same. Right? If you are making up these numbers, you might have 5 in a row, like heads, 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 heads. But after you make up 5 heads in a row, you're probably going to be like, okay, I need to switch. Like, that's too many in a row. They're going to think that I'm wrong, right? But the actual chances of getting 6 in a row is very common, right? So over here, when you actually flip it, 6 in a row is very common. So if he had the list of each one, he would look to see if there's a run of 6 or more. If there was a run of 6 or more, he knew that they actually flipped the coin. If there was not a run of 6 or more, he knew that they made up the flip, right? Because you're not going to put 6 or more heads in a row, because you're going to think that I'm thinking that you're making up the numbers, right? You're trying to make it so that I can't guess whether you're actually flipping it or not, right? Okay? So they make up the numbers. We're going to try it. We're going to do 200 flips and see how common it is. We're going to see how many runs of 6 or more we have in this coin flip, okay? Ready? Let's go over here. 200 numbers. Okay, coin flips. What are we saying? 0 and 1? Okay, we're doing 0 and 1. We're going to see how many runs of 6 or more we get.
Wait, is head 0, tails 1?
It doesn't matter. Well, yeah, sure. Heads is 0, tails is 1, right? We'll do that. Okay, run. Here we go. All right. In the top row, there's 5. Okay, in the second row, I'm going to scroll down a little bit. Second row, we don't have a run of 6. We have a run of 4. Let's see.
No 6.
None here. None here. None here. Okay, there's 6 here. 1, 2, 3, 4, 5, 6. From 70 to 75, because those are in a row, right? That's a run of 6. Okay. Let's see. Zeros right here. There's 7. If you were making these numbers up, you're probably not going to put 7 heads in a row, right? That's 2. That's 2 runs, right? Out of 200, we're not even through the first 100. Okay. Let's see. There's a run again from 100 to 106. That's our third run. Our fourth run of 6 or more is from 114 to 120. Okay, we have another run. Let's keep going on down. Run number 5 is right here. Okay, so we have at least 5 runs of 6 or more in this 200, right? But if you're actually making this data up, you're probably not going to put a run of 6 or more, right? Definitely not a run of 7 or more, right? Because you're going to think that's too many heads or too many tails, and you're going to switch to the next one, right? Okay, so that's kind of how that works, okay? Getting a run of 6 when you only have 2 options is not uncommon, right? So that's kind of what's going on here, okay? Simulate 200 actual coin flips, repeat the simulation a few times, then determine whether a run of 6 heads or 6 tails is pretty likely to happen. We got at least 5 runs of 6 out of 200 coins, at least 5 runs of 6 at least, right? That's kind of how that works. Okay. Let's go to your homework assignment. You're going to do these together. And you have a couple of these. I want to talk through number 1 real quick because I do have kind of a little bit of a typo. We are talking about a professional basketball star, and we are shooting free throws. Okay? So his free throw percentage was 53.6% or .536. Did you see that number right there? There's where it is. Okay? Is that a good free throw percent if you're a pro? That's terrible, right? MJ's like, I could do that. I could do way better than that, right? Okay? So here's the deal. We are simulating 5 free throws at a time, and here's the results that we got, okay? Now, for some reason, I put a 1 represents a free throw that was made. So 1 is a make and 0 is a miss. Okay? But then I went ahead and put yes, no, yes, right? Whatever, okay? So that's kind of weird, but when you run the simulation, you will do 1 as a make and 0 as a miss, right? Okay? When you actually do this random number generator, okay? You're going to do this a couple times. You're going to do the trial. You're going to run the generator 10 times, and you're going to give me the results here. You're only doing 5 at a time, but you're going to do 10 times, and then you're going to do the make percentage, okay? So here's how we would do this. The result, I'm going to use this result, and we're going to put this in this first row just so you can kind of see what we're talking about. But I'm going to put zeros and ones. So 1 is a yes, and 0 is a no. So we have that going on, right? If I convert these to 1s and 0s, they would come down like that. 1, 0, 1, 0, 0. So what's my free throw percentage? What's my make percentage?
40%.
40%. 2 out of 5, which is 40%. They might have you put it as 0.4 instead, something like that, right? 40% is my make percentage. So you need to run it 9 more times and see what your percentage is, right? And see if 0.536 is a good number or a bad number, basically, is what they're asking. Okay, based on the above results, would it be unusual for the pro basketball star to make all of 5 free throws in a game? I don't know. We'll see. Okay? All right. And then the next couple simulations is kind of the same thing. You have baby numbers and all that good stuff. Like number 3, you're just setting it up. You're not actually running the simulation. So how could you use a random number generator, etc.? Okay? And that's all. Is there just a front side to this page? Yeah, just 3 examples, okay? And only 2 of them you're actually running. So there you go. Do you want me to put you into groups? Do you want to be into groups?
We'll
Whatever, you're going to figure it out. What? Me choose them? You choose them?
No.
You choose them? Okay. All right. I don't care how many people you have. I wouldn't do any more than like 4.
Okay.
Because that's a lot, right? Don't do any more than 4. Okay. There you go. Find your groups. Go. I'm going to shut the video off. Everybody say bye, Michelle and TJ.
Bye, friends.
Bye, friends.